Smart grids on industrial areas was the topic of my graduation research for the program Construction Management and Engineering. I performed this research for the municipality of Zaanstad, which is a partner in the European project e-Harbors, which also concerns smart grids. But why are these smart grids so important? Well, a transition is going on to shift from energy from fossil fuels to renewable energy. For instance, from solar power and windmills. Yet these energy sources are uncontrollable and have a random character, which can cause imbalances in the energy supply and threatens the safe supply. To cope with this intermittent energy production is one of the main goals of the smart grid. To investigate the subject, I've done a literature study, consulted many experts, and performed a case study on an industrial area development. For this study, I've developed an agent-based simulation model and calculated a number of scenarios to compare the results. A smart grid is an electricity network adapted to the introduction of renewable energy sources. The production of energy can be distributed, for instance from solar panels, windmills or small combined heat power plants. And the difference is that both supply but also the demand of energy is managed intelligently. This is a fundamental difference in the system and the main goal of the smart grid. This demand management can be applied in industrial processes which have a source of flexibility. For instance, the production of chemicals, paper, cement, wastewater treatment, but also production of heat and cold can have significant amounts of flexibility in it, which can be used in smart grid to cope with the uncontrollable production of renewable energy sources. To find out how this can work, in a case study, an example was given. This case study is the industrial development Hoogtij, on which windmills are developed and also a district heating and cooling system is projected. This district heating and cooling system works with a heat pump which efficiently uses energy to produce heat and cold. To see how this heat pump can work flexible, a simulation model is developed which optimizes the use of energy from the heat pump and the windmill. This model has calculated for 1 year, and the results are that energy costs drop significantly, a CO2 reduction can take place of 73%, and improves the sustainability and the profitability of the area. Conclusion of the study is that smart grids are a requirement for the large-scale deployment of renewable energy. Significant potentials of flexibility can be found in the industry, and this flexibility also has an economic value. I hope that you are inspired by the story and you can read more in my report. Thank you.